When understanding programs, particularly when debugging them, it can be good to keep track of the memory used by your program. We're going to demonstrate a technique called memory diagrams. Memory diagrams are best drawn by hand on a piece of paper as you look through code. We're going to use this example of a simple program here that sets two global variables, x to 5, y to 7, and then resets the value of x to 9, adds x and y together and stores it in a global variable total, and then prints it out. It's a very simple program, but we're going to see how it uses memory. So here's the sheet of paper, and you'll want to use a real sheet of paper because it's just easier to do. And on the sheet of paper, you'll draw an inverted T. The inverted T is used for these memory diagrams. On this side of the T, we'll keep the identifiers or the names. And on this side of the T here, we'll keep the values. So when we trace code, we run it like a computer would run it, and then we come from the first line here and start going down. And everywhere where memory is affected, we're going to make a notation over in our diagram. So the first line says var x equals 5. Now this is JavaScript. In JavaScript, var means allocate a new memory location with the name x, and with this equal sign here says put an initial value of 5 in it. So since it's a new value in memory, I'll put a new identifier called x here, and then I'll give it its value, which is initially 5. Now we go on and look at the next line. Line 2 says var y equals 7. So we'll go over here. Now notice we are going down as we trace the code, but as we put memory in, we're going up in our memory diagram. So I'll put y's value into the memory diagram, and its value is 7. Going on to the next line, we see x equals 9. We don't see var x equals 9, we just see x equals 9, which means we're not declaring a new memory location, we're replacing the value in the old memory location called x with 9. It's important now, when you go over to a diagram like this, that we want to be able to keep track of the values that x, y, and various variables have. In case something goes wrong, maybe we can see where it went wrong. So when we say x gets 9 to replace the value of 5, we don't erase the 5, we cross it out, and then we put the 9. Then it says var total equals x plus y. With the var total, it means I have a new memory location called total, and it has the value of x plus y. So now I have to look up, what's x? I look it up, I see x is 9, and what is y? Y is 7. So having this memory diagram helps me look up the values of x and y, so I can do this expression here. So it's 9 and 7, I'll add them together, and the value is being put into total, so total gets the value of 16. The last thing says print out, or print to the console, total, and we can see here in con that it printed the 16. In our memory diagram, we often want to keep track of output, and we usually do that over here to the left. So the output is 16. So this memory diagram is used to trace this program, and it does so by keeping track of the memory used by the program. A variable x, which was initially 5 and went to 9, y, which is 7, and total, which is 16, producing this output. So the left-hand side, this ID, are the names of the memory locations, and this is the values. This may seem a little tedious to have to draw it down, and in this simple example it is. But when you get into programs where there are function calls, loops that change variables over and over and over again, it really helps keep your sanity and your focus on debugging a program if you can keep track of the values of the variables. So this is a very useful skill, very handy tool to have available to you when debugging programs. And it's a good habit to get into when you're thinking about how code works. Don't try and keep it all in your head, write it down, and you want to write it down in a meaningful kind of formal way. And these memory diagrams are a good way to do that. So don't just scribble things on paper. Scribble it down using a methodology where you have the IDs and the values, and that you go from bottom up writing things as you trace top down. And we'll see some reasons why we want to go bottom up and top down as we get deeper into memory diagrams. But again, writing it on paper is useful, and writing it in a formal way, such as these memory diagrams, is very useful.